Session 3, Part 1, Introduction to Decommissioning and Maintenance. At the end of this part of the session, I want you all to be able to describe in detail the procedure to turn off water before carrying out maintenance tasks. It's one of the most important things you can do. List 4 of the causes of noise and explain how these can be remedied, and explain not even so much the causes of airlocks, but I mean the causes of sort of low flow or no flow, and how to fix them, including airlocks. That would be a good thing to get from this session. So firstly, we're going to look at what decommissioning is. There's sort of two types of decommissioning we need to be aware of. Permanent decommissioning, which is when you're completely removing something and you're not going to replace it. And there's temporary decommissioning, where you sort of take something out just to work on it and you're going to put it back in place again. Worth noting, if you do permanently decommission any installations, you should try and remove the dead legs as far as possible. Dead legs are any sort of length of pipe which don't go to anywhere. So try and remove those dead legs as far as possible, to reduce the risk of stagnation and bacteriological growth in the pipework. Okie dokie. There's two main types of maintenance we need to be aware of. Planned preventative maintenance, which could be sort of any work that's planned in advance. For example, sort of servicing of a boiler, rewashing of a taps on a 5-yearly cycle, for example, before they've become faulty, which might happen in sort of big installations like airports. And there's also emergency maintenance, which is with breakdowns, essentially fixing things when they've gone wrong. In big projects, we might also have some maintenance documents, for example, in industrial or commercial properties, and a maintenance schedule is a plan of all the maintenance work that is to be done. So that's all a planned preventative maintenance that's going to be planned in and would be carried out. But we'd also have a maintenance record on these big jobs, which sort of record not only our sort of planned preventative work that we've done, but it'll also sort of identify reoccurring issues with emergency maintenance, because if things are regularly become faulty and they don't last their normal lifespan, then we can identify that there's an issue there that's causing that, and we can start to sort of try and ascertain what that might be. So yeah, on to fault finding, essentially. So one of the key pieces of information for fault finding is manufacturer instructions. So if something has gone wrong, have a look at the manufacturer's instructions, and inside there, they often have like these fault finding sheets which help you to work out what's gone wrong, essentially, which is really handy. And like I said before, if there's reoccurring in issues, looking at the maintenance record can identify these and sort of give you some clues potentially as to the possible cause. But before you carry out any maintenance work, you need to make sure that you have turned off the water. Firstly, you need to identify the best place to do that, and we're going to sort of talk about that in the next slide or two. And obviously, if it's got powered by electricity, you also need to make sure you isolate the electricity before you work on anything as well, just so you don't get electrocuted. So the procedure to isolate the water is below. So identify where to switch it off. Then before you switch it off, make sure that you tell anyone who might be affected by the water being switched off. And that's not just the person who lives in the house, but generally speaking, it's going to be the person who lives in the house. But if there's other trades working there as well, and you're going to switch off the water to the whole site, make sure that you let them know in advance, particularly the wet trades, plasterers, bricklayers, tilers, because they are going to need water to do their job. And once it is off, make sure you leave a very clear notice where you've switched it off if it's not in your immediate working area, to let people know not to turn it back on, because we don't want to be getting wet. So when it comes to isolating the water, in an ideal world, we would sort of isolate it as close to the appliance we're working on as possible. So if you're working on a float valve and it's got an isolation valve before it, as it should do, you'd switch it off at that valve immediately before the float valve, or if you say, for example, changing a tap on a bath, you'd isolate it on the supplies to the bath if they're there, but they're not always there. So in the instances where we don't have a service valve immediately next to where we're working, we would sort of turn it off at various places depending on the type of system. If it's an indirect cold water system which is fed from a cistern, we would normally sort of turn it off on the distribution pipe immediately after the cistern, so we don't sort of have to drain all of the cistern to actually work on the system, you know. So turn it off after the cistern on the distribution pipe. And if it's a direct cold water system, which is fed directly from the mains, we might then sort of isolate it back at the stop valve, the main stop valve as it comes into the property. But in those circumstances, make sure you inform the customer before you're doing the work, or anyone else who might be affected by the loss of the water. If you're working on the hot water side, it's worth mentioning actually at this point, there should be a valve on the cold feed to the cylinder, so you could switch it off there, or ideally you'd switch it off close to where you're working at a service valve before the appliance. Very briefly touch on electrical safety during and after maintenance. So when you do work on any installations and they are powered by electricity, make sure that you carry out safe isolation procedure like we talked about in safety and in the electrical modules. And if you remove any pipework, again, like we mentioned in these modules, make sure you use temporary earth bonds, temporary earth continuity bonds, like these ones on the left, to bridge any gaps when you cut the pipework, so to reduce the risk of electrocution should the pipes be live. And if you use any plastic fittings or plastic pipework on what was previously a copper system or a metallic system, you need to make sure you use earth bonding clamps, like these ones here on the right, with a bit of supplementary bonding over the fittings you've put in to make sure that you ensure continuity should the pipework become live. So we're going to talk about noise in the cold water systems now, and the causes of noise. One of the causes of noise can literally just be high pressure. The water's whizzing through the pipework really, really fast, and you can hear it moving. Essentially, you can hear the water going through the pipe. Another sort of common cause of noise is water hammer, and there's a few causes of water hammer. One could be if you replaced, for example, a screw down type tap with a quarter turn tap. When you turn that tap off with a quarter turn, it shuts off much more quickly than if you screw it down, for example. And shutting the tap off quickly, essentially the water still has momentum. That momentum is then stopped abruptly by switching it off quickly, and that can cause the water to move inside the pipework, which can cause water hammer, water noise. Another cause potentially could be poorly clipped pipework. If the water's going through the pipework and it's not been clipped sufficiently, the pipe can then move and vibrate. And it can also be caused by float valves switching off quickly as well. It can cause the water to move in the pipework, which can cause noise. Knocking can be caused by poorly clipped pipework. And squealing, if you hear a squealing sound when you switch off a tap, it's probably going to be caused by either a loose jumper plate or a split washer. And that's kind of fairly easily replaced, you know. Okie dokie, so reducing the noise, folks, well, first and foremost, we can make sure that the pipes are appropriately clipped, and that should sort of hold the pipes firmly in position and reduce the incidence of noise. But if velocity noise was an issue, we could fit a pressure reducing valve, and that's going to reduce the pressure, slow down that water, which should reduce the noise from velocity noise. And our squealing with taps and valves, I mean, replacing the washer or potentially replacing the whole of the headgear if it's the jumper plate that was loose or broken. If you have issues with float valves, sometimes it can be caused by grit or rust building up in the orifice, like we've talked about before. And yeah, I mean, just clear it out. It's easy, just literally take it apart, sort of knock it out, wash a bit of water through it, put it back in. And this grit build-up can also sort of cause other issues, such as a reduction in flow, which we're going to talk about now. So grit in the orifice will also reduce the flow rates, and sometimes orifice can get fully blocked, which would mean that we get no water flowing through the float valve. And the same thing can happen with line strainers. Line strainers are there to protect components. They're there to catch any grit or debris that might be in the pipework and stop them kind of going through certain equipment, things like, I don't know, say check valves, reduced pressure zone valves, pressure reducing valves. All of these things have got sort of moving parts in them, which if grit gets into them will cause them to fail, cause them not to work. So quite often we might look to fit line strainers before some of these components to catch this debris and to keep the mechanical working parts of these things safe. But what can happen over a long period of time is these line strainers can and will get all furred up, and will sort of slow down the flow initially and potentially stop the flow of water over time. But the good thing about them is they're designed to be taken apart, like you can see up here, and cleaned out. So that's always handy. So if you've got an issue with low or reduced flow or no flow, and there's a line strainer, first and foremost, have a look at the line strainer and sort of clean it out, essentially. Another issue with sort of reduced flow or no flow can be airlocks, and this is something that happens quite a lot. Essentially, it can happen anywhere where the pipework isn't plumb or level. So if you, for example, have a storage system which the distribution pipe is rising from, or the cold feed pipe is rising from, before you can end up with air getting built up just here, which means that the water can't actually flow out, or you get only some of the water can flow out past it. In circumstances like that, the best thing to do is to sort of level out the pipework, essentially, where possible. Again, you can see this similar issue happening on this vented hot water cylinder here, with the vent pipe sort of going up and then sort of falling here, which means the air could build up there and cause a reduction in flow or no flow of water at all. But this can happen anywhere where pipes aren't level, so you need to try and make sure when you fit pipes, fit them level. If you come across pipes that aren't level, then sort of make them level. And also we could sort of remedy it if there's certain circumstances where it can't be avoided, where pipes have to go up and along and back down. You could fit manual bleed valves or automatic air release valves on them to release any air from the system. Just think ahead when you're doing your installation. So another way you can remove airlocks is by forcing high pressure water into the system, which tends to work. Or if it's a reoccurring issue, like I've sort of mentioned, you could fit this thing here, which is in the middle, which is an automatic air release valve, automatic air vent, or this manual bleed valve just here, or manual air release valve, air vent just here. Okay. If you can't fix a fault, well, you can't always fix something. The first thing you need to do is tell the customer. For example, if you need to replace a tap instead of repair it, and then let them know before you do any changes. Okay. And if you can't fix something at all, well, make sure you tell the customer and tell your employer as well. If you need to, fill out a job record if that's what your company requires, to record the time that you spent there. Now it is time for your task.